the phase 1 results of the statistical analysis. Basically, I've been collecting, the district's been collecting data since the late 60s, and more intensely since 1997, and I worked here in the 04 to 06, ramped it up a little bit more, and it's getting ramped up even more, so we're data rich in the district. So, as I mentioned, I'll do a little recap of that first work that was done last year, sort of the phase 1, just asking some general questions, long-term trends, doing a formal statistical analysis of the lake monitoring data. In phase 2, I also had some objectives pertaining to the things that came out of phase 1, and come up with some recommendations for potential further investigation. You're well aware, there's some, on Lake Minnetonka, there's over 24 sampling stations that are sampled bi-weekly in the summertime. And there are 11 lakes that have long-term data in the Lake Minnetonka, draining into Lake Minnetonka, or at least within the watershed of the lake. The phase 1 study objectives were to assess the number of monitoring stations needed to assess the health of Lake Minnetonka. I mean, it's quite an effort to get boats out there, especially in April when the weather can really stink, and cover all those locations in a reasonable amount of time. And if some of the bays that are adjacent to each other have similar water quality statistics, say an annual basis or monthly basis, you might not, it suggests that you might not need to go to one of those bays all the time. You know, maybe monthly, maybe every other year, something like that. And that was the point of that exercise. The next was assessing the sampling frequency to assess the health. And sort of the health defined by sort of the MPCA, where you're looking at the June, July, August, September values for nutrients, i.e. total phosphorus, sort of response variable, chlorophyll A is a proxy for algal biomass, and then Secchi-DIS transparency. So I'll get into that a little bit more, and then a trend analysis, just very on an annual basis for all of these those water bodies in Lake Minnetonka and the upper watershed lakes. So, and the first objective, again, do adjacent bays have similar water quality? If so, you know, maybe you can monitor them in a different frequency and time. So, for that exercise, we looked, sort of clustered all the bays that might have an influence on one another. So kind of came up with these 6 areas. You see the southwest lakes, Halsted, Cooks, clear down over to Smithtown, and sort of the central lakes. You know, you're probably very familiar with these. So anyway, it was just a way to look and see if there's similar water quality for adjacent or reasonably adjacent bays. So to cut to the chase here, the results were finding that, especially in the southwest part of the lake, in here, there's a number of bays that had similar water quality to adjacent bays. So you can see Smithtown and Phelps. Smithtown is a lot like West Upper. Phelps a lot like Park, and a number of others as well. Carmen's in there, Harrison's. It's a lot similar to West Arm. Forest Lake is similar to West Arm as well. Laurel Lake North, and then the North Arm, very similar to Maxwell's. Now for the second one, is really, you know, can you sample do you need to sample once a month or twice a month to assess the lake health? And I mentioned the MPCA approach to that. And I don't surprisingly or not, but it turned out that there weren't statistical difference between if you sampled once a month or 4 times a year versus 8. And some of you recall it really didn't matter if you sampled at the beginning of the month or the end of the month for those 4 times. So statistically, there's no difference. Or at least you didn't get any more information out of it statistically. Whether you want to, that's just one metric, one reason to sort of reduce sampling. Of course, there's reasons to continue sampling. You might hit an important event, but that's statistically anyway. It was showing that you really only need to sample it once a month. Then the trend analysis. This is fairly simple. It's just looking at, is water quality improving, degrading, or remaining the same? And we looked at just sort of the raw data as it was sampled, and then did some weighting, weighted the variables for adjusting them for annual runoff, and average annual runoff for a given year, the precipitation during the open water season, and then the average air temperature. And finally looking at I mentioned some of the stations had quite a bit of data, and there were about 6 bays that actually had 7 years of good data in the early 80s, and then of course a lot of data recently. So just did a simple comparison to see how those bays were doing. And as a result, for the upper watershed lakes, some lakes were improving with water quality, some did not show a trend, and then the one, Lake Virginia, was showing significant degradation in water quality. Again, with respect to total phosphorus, chlorophyll, and Secchi Dis. For Lake Minnetonka, really didn't see much of a trend. I mean, again, we had 26 bays. You saw some improving, some degrading, but standard deviations were similar in magnitude to the averages, so it makes it really difficult to statistically show a change, show a trend. There's just a lot of variation in a given year. So I don't know what it is, I guess. For chlorophyll, and you'll see this in tables later, a number of bays had increasing chlorophyll. And again, you kind of see a lot of those on the west part of the of Lake Minnetonka. You need to notice that some of the bays had very low chlorophyll, and they only had to bump up a few parts per billion to show a significant difference. So those may not be as much of a concern. For phosphorus, you saw the surface water phosphorus was improving, which was nice. And you see that Halstead Bay is decreasing from 1997 to 2012. Phosphorus and increasing in PV, which is kind of a funny little lake on the north. It's not really a bay, it's just a little sort of lakelet tucked into the north shore. And finally, the Trophic State Index, which sort of is an index that considers Secchi, chlorophyll, and total phosphorus. Any changes that were found in that were basically mirrored what you found in either the chlorophyll or the total phosphorus. And finally, again, I mentioned some of the bays had quite a bit of improvement, both in some of the cleaner bays. Say Wayzata had improved Secchi, phosphorus, chlorophyll between those 2 time periods, and some of the more eutrophic bays like Jennings showed an improvement. Again, there's a long way to go on Jennings and some of those eutrophic bays, but it was good to see that. So that's kind of the end where we left it off. And one of the questions was, for the lakes, for the bays or lakes that had a trend, was there certain months that really contributed to that improvement or decrease in water quality? Point being that maybe you could, potentially target what sort of mitigation you might apply to a lake or a bay. Because if you're getting increased, say, phosphorus in May and June, that would suggest that, it's things to do with the watershed. Some things you might be able to do to prevent prevent that from getting in there. But if it's later in the summer, August, September, that might suggest, well, you might need to focus on the lake, maybe some, alum treatments, things like that. And there's also this dilemma where you saw decreasing total phosphorus concentrations over time, but the chlorophyll concentrations were going up on several bays, which is a little counterintuitive because you'd think more nutrients equals more algae. But the evidence was really, the analysis really didn't bear that out. And that's one of the reasons this phase 2 was kind of kicked off, was to really look at the variables on a monthly time scale for these surface water monitoring stations, and also look at the deep water samples in these water bodies, total phosphorus and then the soluble form, soluble reactive phosphorus, on a monthly and annual time scale. And finally, the last two objectives are really keying in on kind of the big three that have always been kind of troublesome: Halsted Bay, Jennings Bay, and Stubbs Bay. Always have had poor water quality for one reason or another. To kind of look at the relationships between phosphorus and chlorophyll and Secchi-Det. Put it under a microscope there a little more. And then also a quick look at can we relate the stream loadings of phosphorus to the phosphorus concentrations in those bay. Just a cursory look at that. So this, apologize for the dark lines there, but this is a trend analysis for the surface data. And for the, I pointed out there was raw data, and then there was these weighted data. What you're seeing here is if any of those approaches showed a statistically significant increase or decrease of any of those four methods, I put it up there. So it's really, kind of difficult to see, a large number of trends, except certainly Pearson's has done quite well. In all the parameters, you can see the blue bars going across Pearson's Lake. Here we're grouping it by parameters, so Secchi-Dis depth, June, July, August, September, and then the annual mean chlorophyll profile. Down here, we're clustering it by the time period. These are all June, July, August, September, annual. And it's kind of difficult to see any general trends here, but typically if you saw something on an annual basis, you wouldn't necessarily see a trend changing on a monthly basis, but there are exceptions. But basically didn't come out very, anything really jumped out in this analysis. For the Lake Minnetonka bays, this is just by the parameter: chlorophyll, total phosphorus by month, annual. These are those western, southwestern bays. This is the Jennings system, the Stubbs system. This is in the eastern part, the bay, Lower Lake, Wayzata, Grays, etc. And then sort of a smattering of the rest, Lafayette, St. Albans, South and Carson. And the thing that really kind of pops out is there's a lot of poor water quality with respect to, or at least the decreasing water quality or increasing chlorophyll in a lot of the bays, especially on the western, the western and the central bays. You can see those in here. But you're seeing improvements, blue coloration, the light blue, for total phosphorus in those areas. We're sort of seeing that issue not only on the annual basis as we did in phase 1, but we're seeing it in a monthly basis as well. And if you look at by month, June, July, August, September, a lot of the degradation in the chlorophyll and some of the Secchi is occurring later in the summer. So it's really July or August and September, this kind of really where you're seeing the degradation in chlorophyll. Now for sort of the second task is looking at the bottom water quality. At the bottoms of these lakes. These are the upper watershed lakes, and you're really, you're seeing a few phosphorus in the bottom. But in general, you're seeing a lot of significant improvements in the phosphorus in the bottom waters, which is good. Now, if we look at the similar data for the Lake Minnetonka bays, again by parameter, this is the total phosphorus, this is the soluble fraction. You're seeing, in general, where you're seeing the decreasing water quality, i.e. increases in phosphorus in the bottom waters over time. It's Cooks Bay, Peavey Lake, and then some St. Albans, Lower Lake South. But there are a number that are showing quite a bit of improvement. Halstead, Priest, Smithtown, Spring Park, Forest Lake, Lafayette, etc. So those are encouraging signs. By time period, really didn't see, if you saw in general decreasing water quality for a given parameter, it typically happened most of the year, or the open water season. Say Cooks Bay, most months had poor water quality or decreasing water quality, Peavey Lake, etc. And the same for improving water quality, where total phosphorus decreased in those bottom waters. All right, I don't want to go into details here. This is where we kind of shifted gears and looked at the Halstead system, the Jennings, and the Stubbs Bay system. Just looking from 1997 to 2012 data, sort of busting up and getting those averages for Secchi, chlorophyll, and phosphorus. And just briefly, you're seeing the highest clarity in June with these green diamonds, or excuse me, blue diamonds. And then the rest of the year, it's kind of settles in. You can't really see much of a difference between months or the annual mean. For chlorophyll, the blue diamonds, they're lowest in June, which coincides with the improved clarity in June. But the rest of the year, it's kind of a mess. But you do see this trend since about 2007, where it's kind of the scatter has increased quite a bit, and you're seeing a lot of high levels. For total phosphorus, you're really not seeing a whole lot of variation. Bottom trends of phosphorus, not really seeing a whole lot there. Big shotgun. Now, again, I didn't want to go into all those graphs with Jennings and Stubbs, but they were kind of, they were somewhat similar. Now, total phosphorus versus chlorophyll, you might expect increased nutrients equals increased algae in the in a relationship, and you're really not seeing anything fall out there. It's not an apparent relationship there on an annual basis or by month. For Jennings, you kind of see, you do see a relationship along there. It wasn't, there's some significant relationships there. Again, it's a different system. And Stubbs, you're really not seeing much of a very good relationship between the nutrient and the biological response variable. However, for chlorophyll and Secchi disk transparency for the three bays, you see quite a good relationship. Now, you look at the orange, that's sort of what we've looked at all along, is like the annual basis. You see a slight trend, but when you incorporate the high water quality in June and look at it, you really kind of stretch those axes out. You can really see that there's a good relationship between the chlorophyll and the transparency. And this is just another way of looking at it. It's saying, these are significant probability values, it's just an ANOVA test, saying that for Halstead, Jennings, and Stubbs, no matter what the month or an annual, there's a pretty good relationship between chlorophyll and Secchi. However, between the nutrient, phosphorus, and chlorophyll, you're not seeing that. Another way of looking at it, these are looking at all the bays on an annual basis to compare phosphorus and chlorophyll and Secchi. What you're seeing is not very many significant relationships with phosphorus and chlorophyll, but a whole lot of good relationships with chlorophyll and Secchi. Whether this is a systematic phenomenon in the lake, can't really say at this point. Now, the upper watershed lakes, those 11 lakes, kind of looking at that, they have a few more good relationships of ties in between nutrients and chlorophyll, but most of them had a great relationship between chlorophyll and transparency. one of the things that really kind of stood out to me is that when I started looking at these relationships for Halstead, Jennings, and Stubbs, kind of put a date on these points, and looking at the late 90s to say 2005, and then 2006 to 2012, seems to be kind of a shift going on. What that means, or if it's real, I'm not sure. So basically, it's saying prior 2005 and prior, you could have a high level of chlorophyll. You get phosphorus, and you get a certain amount of chlorophyll. After that time, 2006 to present, you have decreasing phosphorus, but you have higher chlorophyll. It's like, what's going on? Very strange. You'd think you get less nutrients for the algae. So, what's going on? Again, these are pretty high levels, relatively high levels of nutrients. Anyway, you're around 100 parts per billion in there, a little less than Stubbs, but what that means, kind of left it at that. And finally, looking at just a quick look at the loads, the amount of phosphorus coming in to Halsteads, Jennings, and Stubbs from their respective creeks. Again, you're not seeing a really great relationship between phosphorus and coming from the creek, the load, and then what's in the bay. Halstead's in 6 miles, pretty flat. There may be a relationship. There's a relationship between the load from Painters Creek into Jennings Bay, especially as a summer average average. And Stubbs Bay, you're not really seeing great relationship there. Again, this is kind of a cursory analysis. It's nice to show that that relationship between what you're doing in the watershed might have an impact on what's going on in the bay or the lake. And this attempt, it really wasn't really showing that, except for maybe for Jennings. Kind of gives justification for what you're doing on the watershed. Go ahead.
I'm just curious, what's the residence time of most of these bays? Are they over a year? I think Halstead was, I can't remember though.
Might be, yeah, I'm not.
Part of it might be the trend looking at too is, if you got over a year residence time, you got to look over the last year's worth of loading to look at that response.
Yeah.
And then there's the settling term that's associated with that too.
Yeah.
So there might just be some staggering of looking at it 6 months, year and a half.
Yeah.
Through those trends to try to figure out if there's a residence time issue that you're not picking that up.
Yeah. Agreed. There could be, that and other reasons as well. Is there some lag time happening in here? With this kind of hoping for something to pop out really nicely, but again, as Joe's pointing out, there's so much else going on. So, in concluding that monthly averages weren't closely aligned to the annual averages for the water quality variables. And that's on the surface water. And the bottom phosphorus, if you've found a trend on the annual scale, there's at least ones that showed a similar trend. Not surprising. Looking at the Halstead, Jennings, and Stubbs Bay, again, chlorophyll and Secchi were pretty correlated, or highly correlated with one another, whereas the connection between phosphorus and chlorophyll was not totally apparent. Sort of as strong as the chlorophyll in Secchi. And again, there's sort of a shift in the phosphorus and chlorophyll relationship around 2005, which is still puzzling. And again, at least in the approach I took, there wasn't a strong relationship between phosphorus loading and this bay surface phosphorus. And again, this is a very simplistic approach that I took. Future directions, again, these are things that Joe brought up, provide a stronger connection between the phosphorus loading and the bay. Phosphorus, again, there's hydraulic residence time, turnover, there's stratification. So there's a lot of stuff going on in there, and that might be of interest for further investigation. And also, what are the primary drivers of chlorophyll in those bays? Again, what is driving them? It isn't evident that phosphorus is. Obviously, it is a component of it. But perhaps there was a shift that took place, I showed in the mid-2000s. Is that due to different species of phytoplankton, quality and quantity of zooplankton, it's grazers coming in? I don't think you could really tag it to zebra mussels, but and then using an advanced statistical technique, because there's a wealth of data out there. Maybe there's some interaction with internal loading, the nutrient nitrogen, water temperature, and stratification, and then the other plankton measures. So anyway, that's kind of where it left off, and everybody's still awake, so a little dry, but anyway, take any questions if you have any. I think in the future, I think there might be an analysis of stream water quality data in a year or two, but.
Did you look at nitrogen limitation at all, the possibility for describing that? I mean, just looking at those, N-to-P ratios in those lakes to see if it's driven below that Redfield ratio?
No, that wasn't part of the task. I mean, it's certainly
That
something.
might be part of it. It might have shifted from a nitrogen limited system to a phosphorus limited system during those times. The other thing that can describe that fish change, a major change in fish community,
Mm-hmm.
which you put up there in zooplankton. So if you look at the DNR trend to see if there's any major changes in those fish communities,
Mm-hmm.
see if that coincides with some of those shifts.
Yeah. That certainly could be part of it. I don't know how often they're doing fishery studies on those, at least those 3 bays. But
Every 5 years, usually, don't they? That's DNR, so it's a pretty good trend usually.
yeah.
With Halstead Bay, it's such a big panfish community. It can be kind of almost nuts a little bit with barley and mud. You almost wonder if you had some panfish booms that coincided with throwing that whole relationship off.
Mm-hmm. Yeah, I just remember out on Halstead, it just seemed like there's so many lignans and tannins in the water, kind of tea colored. So I just wonder if that's like the vegetation, a lot of the floating islands and mud lake, the cattails and other vegetation senescing and putting out those lignans and tannins. Of course, it's an outlet of a major wetland system, is what receiving waters from that whole 6 Mile Creek system. That maybe phosphorus did go down. Maybe it opened a window and increased clarity slightly. I don't know. It's again, the Secchi measurements is so variable over the year that's probably not the way to measure it. You probably need one of those Lycor probes on a regular basis to really characterize the light environment.
You have a pretty good relationship between chlorophyll and clarity.
That's true.
So that suggests that the clarity is mostly driven by your algal production.
Mm-hmm.
I'd be surprised if the light limited that was really what was.
Yeah.
It's possible, I guess, but.
Yeah, I just found it just odd that the phosphorus is showing kind of a shift, but you're getting more. That's why more chlorophyll. That's why I was wondering if there was a shift in the phytoplankton community. But unfortunately, intense data hasn't been collected over that entire late 90s to present period for those bays.
Yeah, it's very shallow lake-esque in that, that for so long your chlorophyll relationship, TP relationships just haywire until it goes back to your water state.
Mm-hmm.
Halstead Bay is, that continuum, it's a deep lake with shallow lake characteristics, is what I would say.
Yeah.
Kind of one of those things, so.
Yeah, Halstead's
We'd have a strong influence there.
kind of the detention basin for 6 Mile as well.
Once it happens.
I wonder if I think there's been a lot of notches dug between bays 100 years ago. That's my gut feeling. And I just wonder how strong the connection was between Halstead and Priest Bay, or Stubbs and Maxwell Bay. Was that a real connection, before people started going in and cutting deeper swaths under there? I don't know. I'll have to look it a really old map. You know, some of those connections are real, and people probably went in and said, all right, let's dig it a little more so we can get our boats through there. But some of those, I just wonder. Like in Stubbs Bay, you get this nice spit of land coming from west to east, and then kind of goes up into that property, and then boom, there's a way to get through, and it's very straight and narrow. And so, you know, so I would just wonder if things have changed, or things were different a long time ago, and Halsted was more or less kind of a terminal point, except when lake levels got really high, and it busted over into the rest of the lake, but you never know.
So for your weighting, did any of those come out as kind of driving the trends in your,
It was kind of hit and miss, you know, and whether it was a real relationship or not, it's just hard to tell. You know, you're looking at sort of an annual average runoff for the entire basin, or the upper basin, and you're weighting the factors by that. So nothing really popped out as a strong driver. Yeah. Yeah, you know, the Stubbs, Jennings, and Halsted have just been a real mystery for a long time, you know, or they've been a focus of mitigation measures, trying to understand what the system is. You know, before they took out the Maple Plain sewage treatment plant, it was really bad over there. And what was it? For example, in the late 60s, Wayzata Bay had the same water quality that Stubbs Bay has today. And so it was much worse. So you took away that huge point. You know, I think that went offline in '86 in Maple Plain. Yeah. So, you know, I'd like to know the answer. What's going on? But anyway. Thanks. Welcome.